All right, hi year 11s, this is Mr. Lim here again, and this is our video on pH calculations, the first of two. All right, so let's get started. Okay, so we're gonna be learning about some stuff, more math. All right, so let's have a look. When acids are placed in water, they will produce hydronium ions. Okay, so if we knew that, that's what acids do, right? The concentration of those hydronium ion presents will have different effects. Okay, so if you've got a lot of hydronium ions or a very few amount, they're going to do different things. So it's important to know what the concentration of hydronium is or how acidic a substance is, right? So when they say something is quite acidic, they really mean is that it's got a high concentration of hydronium ions, right? The concentration of hydronium ions can be expressed as moles per liter. That's stuff we've already done before in aqueous solutions. However, in chemistry, we deal with very high concentrations of acids, generally more than 1 molar. All right, so in chemistry, we deal with that. However, in normal daily life, the concentration of hydronium ions is quite low, right? Anywhere between 1 times 10 to the negative 14 to 1 times 10 to the negative 1, which is like 0.1, right? So 0.1 to 0.0 with like 14 zeros, 1. All right, so quite small. Because this is the normal range of concentration of hydronium ions, that means like this range, which is the very small one, not this range, okay? Because chemists, we deal with high concentrations, but in general daily life, there's very low concentrations. So because this is the normal range, we have a special scale or unit of concentration for that particular range, that's this very small range of hydronium ions, called the pH scale. Right, so we're dealing with the pH scale, and you've probably gone through this a little bit in year 9. Okay, so that's not supposed to say concentration grams per liter. Mr. Lim, why you not fix that? Meh, doesn't matter. All right, so the equation to work out the pH of something is pH is equal to negative log concentration of H3O plus. So the square brackets means that you have to use the concentration of hydronium ions, not the moles, okay? So this is the most common issue when people do these calculations, is that they use the moles of the hydronium ions, not the concentration. So you really have to pay attention, and you have to use the concentration, not the moles, to get the pH. All right, pH is a scale based on the concentration of hydronium ions in moles per liter, but it is a logarithmic scale. That means it increases by a scale of 10 every 1 unit of pH scale. All right, so for example, if I have a pH of 1 versus a pH of 2, it is 10 times, going between these two, it is 10 times more concentrated or 10 times more dilute. All right, and if I go to pH 3, that's another times 10. So if I go from 1 to 3, it's a times 100. Okay, so times 100. Let's have a look at some calculations for those. Okay, so let's have a look. So if I have 1.2 mole per liter HCl, now what you'll notice is that all of these acids are strong acids, because we remember that strong acids will completely ionize, which means they'll turn completely into hydronium ions and their negative ion. But weak acids will only partially ionize. And if weak acids only partially ionize, their concentration of H3O plus ions will be significantly lower. So generally, you're not going to be asked to work out the pH of weak acids or bases, because you can't, because you don't know necessarily how much they ionize, or not at least in this course. All right, so we're going to be dealing with strong acids here, so let's go get started. Okay, first one here. All right, so that one is moles per liter, so I don't have to worry about converting it into concentration, because it's already in concentration. So all I need to do is pH equals negative log concentration 1.2. Okay, so on my calculator, what you need to do is find the negative button. You cannot use the minus button, or not on every calculator you can't. Right? So you find the negative button, press the log button, and then you type in 1.2. Right? And you'll see, if you're not sure about where to find the log button or your negative button, well, you should definitely know where your negative button is, but if you're not sure about your log button, come see me in class and we'll work that out. Right? And this is a pH of negative 0.79. Okay? You should not be afraid of having pHs in the negatives, nor should you be afraid of having very high pHs above 14. So you may have heard pH 1 to pH 14 in year 9, but there's nothing wrong with having a pH higher or lower than 1 to 14. All right? That's just mathematics. That's just how it works. Any concentration over 1 mole per liter will actually be a negative value. All right? So let's try the next one. Okay, pH of a solution, which is 0.2 HNO3. So that we just change that number to 0.2. So again, you find the negative log 0.2, and that now is 0.699. Okay, that's the pH there. As we get smaller concentrations, okay, so now we're going to get a smaller concentration. So now we've got 0.002 mole per liter. Now, let's have a look what you get. Negative log 0.002. Okay, now you get 2.699. Okay, so what did we notice about this one? This one here was a negative value. This one here was like 0. This one here is like 2. So what you'll notice is that as the concentration of acid goes down, the pH goes up. So concentration of H3O plus is inversely proportional to the pH. Right? And it's a logarithmic scale. So the idea is that as your concentration goes up, the pH goes down. Or if the concentration of hydronium ions goes down, the pH will go up. All right, so let's look at the next one. All right, so you do need to make sure you know how to use the exponential function on your calculator, because now we're going to be using it a lot more. So this is 1.3 times 10 to the negative 4. So you need to know how to use that exponential button rather than just using the power button. So it should be negative log 1.3 exponential button negative 4, right? And that will get you 3.89 as the pH. There's no unit for pH either, right? If you want to have a go, pause the video and try the other ones next, because they're going to have a little bit more calculation, okay? So let's have a look at the next one. 0.2 moles of HCl in 5 liters of water, so therefore we can work out the concentration of HCl is going to be equal to N on V, which will be equal to 0.2 over 0.5, which happens to be 0.4 mole per liter. Therefore, the pH is equal to negative log square bracket 0.4, which is equal to 0.398. Okay, so there's that. What about 3 grams of HNO3 in 600 liters of water? Oh, whoops. Okay. Mr. Lim did not read this one correctly, so this is not 0.5, this is actually 500. So this is a tiny number. Mr. Lim's going to fix that. That's why I should always read the question carefully. 0.2 divided by 500. So this is now 4 times 10 to the negative 4. So negative log 4 times 10 to the negative 4. Or if you're clever, you can use the answer button in your calculator. Negative log answer, and you get 3.398 as the thing. All right, so a much higher value. Okay, let's do the next one. Now we have to work out the number of moles. So number of moles of HNO3 is equal to 3 over 63.018, which equals 0.40046 moles. All right, now remember, I cannot use the pH yet because I haven't got the concentration. It has to be in concentration. So now I got to get the concentration of HNO3, all right, which will be equal to N on V, which will be equal to 0.0476 over 600, which will be equal to some value, 7.934 times 10 to the negative 5. Okay, now Mr. Lim actually did something wrong in the last calculation. He didn't do this step. He need to do this step. So you should recognize that you can only do pH of hydronium ions, and I used the pH of the concentration of hydrochloric acid last time, but because it's equal, that's okay. But you should still state that the concentration of H3O plus is equal to the concentration of HNO3 because they're split 1 to 1 to 1. All right, so therefore now I can do pH is equal to negative log square bracket 7.934 times 10 to the negative 5 square bracket, which is equal to neg log answer 4.1, and there's no pH, there's no unit for pH. Right, then over here, last question, what have we got? We've got a question where we're adding certain things together. Come on, delete. Okay, not very helpful. Okay, so we're adding two solutions together. All right, so we're gonna have to find out the number of moles of hydrochloric acid, number of moles of nitric acid, add them together, work out the concentration of hydronium ions, and then work out the pH. So, number of moles hydrochloric acid will be equal to, what's this gonna be? CV 0.2 times 0.02, which is equal to 4 times 10 to the negative 3 mole, which is the number of mole of hydronium ions from the HCl. So I'm going to actually do this at the moles level because that makes most sense. All right, times 1, which is equal to 4 times 10 to the negative 3 moles of the H3O plus from the HCl. Then I can work out the number of moles of nitric acid, HNO3, which will be equal to CV again, which will be equal to 0.3 times 0.05. I'm going to save this number here because it's always good to save numbers. 0.3 times 0.05, 0.015 mole, and the number of moles of H3O plus is going to be equal to the number of moles of HNO3, which will be equal times 1. Should be equal to 0.015 mole, which I'll save as B. Right, so now I say, okay, well, what's the total number of moles from the HNO3 and the HCl? So the number of moles, actually, I guess I'll do it over here. Right, the number of moles of H3O plus total will be equal to A plus B, or the number of moles of H3O plus from the HCl plus the number of moles of H3O plus from the HNO3, which will be equal to 0.019. Do I just put this in the pH calculation? No, because I got to get the concentration. So the concentration of H3O plus will be equal to, now we got to think, it's N on V. The N is here, we worked that out, but we're gonna use a volume of 70 mils. Why do I use a volume of 70 mils? Because you've added 50 mils to 20 mils. Okay, you've added 50 mils to 20 mils, so you got 70 mils in total, so you got to think about the total volume. Okay, that gets you 0.271 mole per liter, and then you can work out the pH by negative log that number. 0.271, which equals, negative log answer 0.566 as the pH. All right. Okay, now you can also solve for the concentration of hydronium ions if you're given the pH as well. All right. So the equation is the concentration of hydronium ions is equal to 10 times 10 to the power of negative pH. So that's to the power of, right? So how do we do that then? So let's go do this one here. Concentration of H3O plus is going to be equal to 10 to the power of negative 4.5. this is why you've got to use your negative value, and you've got to work out your power value. So 10 to the power of negative 4.5, right, gets you 3.16 times 10 to the negative 5. Okay, you can also use your exponential button, I think. Negative 4.5. Nah, if you use your exponential button, you need to have a 1 times in front of it, but yeah. All right, so 1 times 10 to the negative 5. Right, so that's how that one works. Okay, so you can just replace the other numbers. 1.5, 10 to the power of negative 1.5, 0.0316. All right, so that one's the 1.5. I didn't even write that in. Okay, so now let's move on to the next one. It's just the same thing, but with the 8.9. Okay, so let's do the 8.9. So it's 10 to the power of negative 8.9, which gets you, what? 10 to the power of negative 8.9. 1.26 times 10 to the negative 9 moles per liter. So remember that you need to get the unit there, okay, because this is the concentration of H3O plus. Okay, you should be able to do the other two, right? One that I might highlight is what happens when you get to pH 7. Okay, so what happens when you get to pH 7? So you do 10 times 10 to the negative that one. So 7 pH is 10 to the power of negative 7, and that's 1 times 10 to the negative 7. All right, and why is 7 important? Because 7 is neutral, right? Or that's what we understand 7 neutral to be. In year 12, you learn about it slightly differently, but we'll see how we go. All right, so let's go to the last one. So 14 mils of pH 1.7 hydrochloric acid is added to 36 mils of pH 4.3 nitric acid. What will be the final concentration of hydronium ions? So let's go do that one together. Okay, maybe move this down a bit. All right. Okay, so first of all, we can work out the concentration of hydronium ions in the 1.7 will be equal to 10 to the power of negative 1.7, which will be equal to 10 to the power of negative 1.7 will be equal to 0.0199, or that's just going to be 200. Okay, so that's the concentration there in mole per liter. So then I can work out the number of moles of H3O plus in for 1.7. Okay, so that is going to be CV 0.02 times 0.1014, which happens to be, now I'm just using the saved number, so 2.79 times 10 to the negative 4. Okay, that's the number of moles of H3O plus from that. Okay, so I just save that as A. Then I've got the concentration of H3O plus from the 4.3 solution, the nitric acid, is 10 to the power of negative 4.3, 10 to the power of negative 4.3, right? So that's going to be 5.012 times 10 to the negative 5 mole per liter. Okay, now I can work out the number of moles of H3O plus from that 4.3 solution, right, which will be equal to CV, which will be equal to 5.012 times 10 to the negative 5 times the volume, which will be equal to 0.036, which will be equal to that times 0.036, okay, will be equal to 1.804 times 10 to the negative 6, which will be moles, and I will save that as B. Right, so then I want to work out then the concentration of H3O plus. So then I would go, so what's the number of moles of H3O plus total, which will be equal to A plus B, which will be equal to 2.811 times 10 to the negative 4. Okay, notice how this number here and this number here are quite similar. because when you add only a tiny bit, right, it's not going to change by a lot. Okay, because this 10 times 10 to the negative 6 as compared to 10 times 10 to the power of negative 4, this makes that significantly smaller. All right, so now that you've got the total there, you can go work out the concentration of H3O plus, which will be equal to N on V, which will be equal to 2.811 times 10 to the negative 4 over, now remember, we've got to add the volumes together. That's always catches kids out. So that's going to be 0.05 because it's going to make 50 mils in total, right? And so that's going to be 5.62 times 10 to the negative 3 mole per liter. Okay, so that's how you might do that one, and that's that for this part of the pH calculations. Next up, we'll be learning how to do some fancier stuff. Adios.